You have started the supported protocols part of the webinar. The slide shows a simple star topology network based on switches without management. The main reason why we still encounter this outdated solution is probably the low price of these devices. The problem is that this solution does not meet current security requirements with its properties. Among other things, it is contrary to the valid European standard EN 62676-1-2. The standard specifies minimum requirements for video surveillance systems used in security applications. In particular, the standard requires video surveillance systems in security applications to detect the failure of any device in the network, such as switches, routers, and cameras, detect the loss of network connectivity between any two system components, for example between cameras and recording equipment, automatically switch to backup communication route if the primary connection fails, generate a fault report or alert in case of any network-related problem, including the type and location of the fault. All LAN-RING switches meet the mentioned requirements of the EN 62676-1-2 standard and therefore enable, among other things, detailed monitoring using the encrypted SNMPv3 protocol. An older version of SNMPv2c is also available, but it is not secure and recommended for security applications. All variables that can be read or set using SNMP protocols are divided into so-called MIB files. These are further divided into public and private groups in the tree structure. See the image on the right. MIB files in the public group are also available for third-party switches, while private MIB files are only available for LAN-RING switches and allow you to perform advanced operations not available for other devices. Typical examples of the use of the SNMP protocol are, for example, monitoring and control of PO power supply, monitoring of RS-485 ports or the state of the optical ring, relay control, sending SNMP traps in the event of an authentication error by the 802.1x protocol power failure and similar situations. LAN-RING switches support all SNMP communication modes, namely SNMP GET, SNMP trap and SNMP set. SNMP set is used to control the outputs and settings of the device itself, while SNMP GET and SNMP trap are used to monitor the device. SNMP GET requires a request to be sent for each read value, which takes some time. SNMP GET is therefore not suitable for monitoring a large number of inputs. In such cases, it is better to use the SNMP trap method, where statuses are sent spontaneously when the value changes. SNMP trap is automatically sent if, for example, the supply voltage goes outside the required range, when the tamper connected to the alarm input of the switch is disconnected, or when the optical circuit is disconnected, for example. The options for monitoring the system using SNMP are extensive for LAN-RING switches. With their full use, the system operator thus has very detailed information about the functioning of the system. Thanks to the SNMP protocol, the LAN-RING system is supported by a whole range of integration and monitoring software and add-ons. LAN-RING switches support the segmentation of the network into so-called VLANs, including the marking of forwarded frames with priorities, abbreviated QoS. Collectively, these settings are described in the IEEE 8021Q standard. Systems with properly configured VLANs and priorities are more secure and reliable. Why? VLANs separate systems that may not be connected to each other. Data frames with a high priority set have lower delay and jitter during their transmission over the LAN. We will discuss this in more detail in the section regarding RS-485 bus support. Setting VLANs and priorities is compatible with switches from other manufacturers. LAN-RING switches can also assign VLANs and priorities to frames coming with RS485 ports and other inputs. VLAN settings can be changed at any time using software interventions. If the system is extended to carry the RS485 buses of the Galaxy, Asset or MB Secure security systems, just create a new VLAN and assign the RS485 ports a high priority of 6 or 7. This will guarantee that RS485 frames will be automatically sorted into output buffers number 3, which ensure their priority handling and thus reliable communication of security systems. Another protocol supported is IEEE 802.1x for user authentication. It has weaknesses in standard implementations. It is capable of blocking network access to unauthorized users, but that's about it. In our implementation, we have added an important feature to help you increase security. An unauthorized attempt to access the network can thus be without delay SNMP trapped to the visualization software. Thus, a potential attacker could be caught immediately and would not have time to break into the network. Another possibility is the transmission of SNMP notifications to security personnel. In this case, the SNMP trap is first received by the IPLOG control unit and then forwarded to the set telephone numbers. In addition, the program launched in IPLOG can condition the sending of SMS with other conditions, forward notifications to the alarm system, visualize notifications in integration software, and so on. Unicast TCP and multicast streams usually have the biggest impact on traffic load. Multicasts only make sense to use in systems where multiple clients need to watch a single stream at the same time. In this case, IGMP group support is enabled on the switches. A new client requesting to display an already existing stream does not create a completely new connection. The switch just forks the stream to another Ethernet port. When using multicast streams, one must also be aware of their disadvantages. In devices without IGMP support, multicasts behave like broadcasts and can overwhelm the entire network. Unlike TCP, multicasts are blocked in routers. Unicast TCP communication contains, unlike multicast, self-healing mechanisms that allow a lost or corrupted frame to be requested. For these reasons, the use of TCP streams is still prevalent in IP-CCTV. Jumbo frames are longer than standard Ethernet frames of 1,522 bytes. They are usually 9,000 or more bytes long. Using jumbo frames can increase network performance and reduce CPU load. However, in order to use jumbo frames throughout the network, all devices on the network must support jumbo frames. It should also be kept in mind that the use of jumbo frames may be inefficient or even undesirable in some cases, such as when data streams are small. Most of our switches support jumbo frames, see table. LLDP or Link Layer Discovery Protocol is the second layer protocol of the OSI model LLDP defined in the IEEE 802.1ab standard. It allows network devices to obtain information about neighboring devices and their configuration. The LLDP protocol simplifies network management by providing detailed information about the network topology. It provides basic information about neighboring devices, such as device types, port identifications, and protocols used. This information can be used to optimize network configuration, improve performance, and detect network errors. We use this protocol, for example, in the Simulant configuration software. With the help of the LLDP protocol, Simuland is thus able to detect and plot the interconnection of the entire network. Our automation customers will certainly appreciate the possibility of connecting Modbus devices. In addition to LAN ports, where any Modbus TCP device can be connected, most LAN-RING switches also have RS485 ports with Modbus RTU mode. All I/O modules and sensors of our production communicate with the Modbus RTU protocol. Up to 30 of these can be connected to one RS485 interface. When logging important events or sending them via SNMP traps, it is important to pass along with this information the exact time when the event occurred. Therefore, the SNTP menu is available in the switches for setting the time synchronization. The ONVIF protocol facilitates the integration of various devices in IP-CCTV, increasing the efficiency and security of the network. Before its expansion, interoperability between manufacturers was a big problem in particular. Basically, each manufacturer used their own proprietary protocol to control the cameras. With the advent of the ONVIF protocol, this problem disappeared. Both LAN-RING switches and IPLOG control units can therefore turn to IP camera presets of all manufacturers supporting ONVIF and its s.r.o profiles. A typical scenario is to send a preset command to the camera in the case of motion detection by a motion sensor, or in the case of opening a switchboard. Another option to effectively use the ONVIF protocol is the analytical functions of IP cameras. These generate a number of interesting ONVIF events. See the list of events on the slide generated by the Pelco fixed IP camera. One of the scenarios used in practice was this. To increase the security of the system, the customer used the ability of the camera to detect cover, to detect movement in a relatively large area, distinguishing its direction and the distance to the object. Through IPLOGs, this information is transmitted directly to alarm systems, lighting and other actions are controlled. The LAN-RING IPLOG system has a number of other tools, interfaces, and protocols available, especially when it comes to IPLOG. They can be divided into several groups. One of them is the so-called open source tools for IPLOG downloadable using OPKG packages. Another group are general protocols enabling the connection of devices from different manufacturers. Creating programs using these protocols is simplified by function blocks. When creating a program, it is enough to use the appropriate function blocks without the need to know the details of how the protocol works. And the last group are the proprietary protocols that IPLOG uses when communicating with specific systems. That's all for the content of this webinar. Finally, I would like to mention some information about the test procedure and the subsequent issuance of certificates. Tests are only mandatory for people registering projects on our website and in the case of applying for an extended warranty of 5 years from the end of production. In both cases, you must have a valid certificate and activated VIP access on our website. The VIP account is activated automatically after passing the test. We consider a test with at least 2/3 of the answers correct to be a successful composite test. You have 2 attempts to pass the test each day. The validity of the certificate and VIP access to the website is 6 months. During this time, you can extend your VIP status at any time by taking another test. Another way to get VIP access is to participate in face-to-face training. In this case, your VIP access is activated for 1 year. Finally, thank you for your attention and I look forward to hearing from you on the next webinar.